Hello ladies and gentlemen, my name is Mr. EDK and today I'm going to teach you guys how to determine if something is linear or exponential just by looking at a word problem. So ladies and gentlemen, this prompt here that I found says identify whether each of the following items best fits a discrete or continuous model. For those of you guys who know what discrete or continuous is, great. If not, don't worry about it. This video is about linear and exponential. Then determine whether it's a linear, arithmetic, or exponential, geometric relationship that is being described. Now, arithmetic and geometric are very specific types of linear and exponential graphs. If you don't know what arithmetic and geometric are at this point, that is fine. We are focusing on today whether these word problems are defining a linear relationship or an exponential relationship. So as a quick reminder, linear is anything that can be written as mx plus b. Okay, so something that has a constant growth and some starting point, versus exponential is something that starts somewhere and then increases or decreases at a constant multiplier. It can be written as a times b to the x power, where this is my constant ratio, which means that every single time I change from one item to the next item, it either increases or decreases by a different amount. And normally that amount can be found by multiplying. So a constant ratio. So when I'm looking at these, I'm asking myself the question, is there a constant growth? Is it growing by the same amount every single day? So let's take a look at here, question number 5. The freeway construction crew pours 300 feet of concrete in a day. So what is my change every day? It changes by 300 feet every day. So as an example, if I talked about day 1, I might have 300 feet. In day 2, I would have 600 feet. In day 3, I would just add another 300, that's 900 feet. So if you notice, I'm adding the same amount. That is a constant growth. Therefore, question number 5 is linear. Question number 6. For every hour that passes, the amount of area infected by a bacteria doubles. Well, doubles is one of those magic math words that implies multiplication. With nothing else, I'm going to go ahead and tell you right now that because it's doubling, we are multiplying by 2, therefore this is exponential. Question number 7. To meet the demands placed on them, bricklayers have started laying 5% more bricks each day. I'm going to give you guys a little hint. Whenever you see a percentage, most of the time, it's going to be multiplication. And because it's multiplication, it's going to be exponential. Question number 8. The average person takes 10,000 steps in a day. So again, this goes back to what happened up here. In a day, we're adding the same amount. In a day, we're adding the same amount. So every day, we're adding 10,000 steps to our daily routine. Because of that, this is going to be linear. This follows that same path of adding the same amount. Question number 9. The city of Buenos Aires has been adding 8% to its population every year. Again, there's that percentage. Yes, it says adding, but 8%, which means that we're having to do some kind of multiplication and then adding a variable amount, because 8% one year might be 800 people, while 8% the next year would be 805 people. It's different. And then the following year, 805 people might be 812. And so it's not the same population added every year. It's a multiplication. So we will talk more about that in a moment. So this one is exponential. Question number 10. At the headwaters of the Mississippi River, the water flows at a surface rate of 1.2 miles per hour. So I'm asking myself the question, is this multiplying by a certain amount every hour, or is this just consistently moving at 1.2 miles per hour? And that's how I read it. I read this as it is constantly moving at a rate of 1.2 miles per hour. So this one right here would also be linear. So really quickly, the percentage ones. When it came to this one right here, it was obvious what we were doubling, what we were multiplying by. But these percentage ones, not as easily determined. When it comes to percentages, when you add or subtract, ladies and gentlemen, when we are increasing or decreasing by an amount, we revolve around the number 1. Why the number 1? Well, any number times 1 will equal itself. So if I want a to increase by a certain amount, and he needs to increase by that 5%. So let's say I was taking this, the bricks from one day, and let's say I laid 500 bricks on one day, day 1. How do I find day 2? Well, I would take 500, I would multiply it by 5% and add it to this. So I want to add 5%. But there's a faster way. I want to multiply. And the way that I would multiply is I would take this number right here, and I would multiply by 1.05. Why 1.05? Well, I just told you that A times 1 is equal to A. So 500 times 1 is going to give me 500. And this part right here is my percentage of increase. So I'm adding 5%. So I'm taking my 1 and I'm adding 5%. And 5% as a decimal, as a reminder, 5% as a decimal is 0.05. And 0.05 plus 1 gives me 1.05. So ladies and gentlemen, this was my lesson on how to take a word problem and determine whether or not it's going to be linear or exponential. In addition to that, I added one thing at the end, which was I wanted to show you guys why do percentages turn into exponentials. It has to do with you are increasing not by a constant amount, but you're multiplying by just a little bit above 1. I hope this helps, ladies and gentlemen. Good luck, stay safe, and see you next time.